Hello everyone, myself Ritu Singh, an assistant professor from LIT Sarigam, is going to teach you irrigation engineering. One of the important chapters is diversion headwork. So today we are going to deal with that chapter. So let's start. The content over here is what is diversion headwork? Means type selection of the suitable site for the diversion headwork. This component causes of failure of the structure on pervious foundation, and one important scientist who has discovered various formula regarding the pervious foundation is Khosla theory, design of concrete sloping glacis weir. So this content we are going to discuss in this lecture. So first we need to understand that what is headwork, what we are calling as headwork. So any hydraulic structure which supplies water to the off-taking canals is called headwork. Means suppose you are having source of water here, means river or rivers, in the sense rivers or any source of water you are having, then you are supplying water. You want to take the from the canals, you have to lay out the canals from where you want to irrigate your irrigated land. So for this you have to build one hydraulic structure over this structure, so that we can safely take out that water to the canal. So that headwork, that hydraulic structure is nothing but headwork. Okay. So these headworks are divided into two parts, like storage headwork and diversion headwork. One thing is storage, just we have to do the storage, like if you are preparing one dam over this dam over the surface, like you are having here source of water and you need to off take the canals from here. So you need to construct the dam over here, so the water will get the store up, that is head of water will create. So there are two types, one to store, just to store, and other is to divert, as well as store and divert the water. So two types of headwork we are having. Okay. So what is storage headwork? This dam is constructed across a river valley from storage reservoir known as storage headwork. So in the last slides only I discussed you the one dam is constructed over the rivers. Okay. What is supplied to the canal from this reservoir through canal regulator? So this is form of reservoir. What is reservoir now? You can question. This is source of water here. You have constructed a dam over this area. So this catchment area is nothing but reservoir. The water collected over the upstream side is nothing but reservoir. So what is supplied to the canals from this reservoir through canal regulator? So we have one more hydraulic structure, that is canal regulator, from which we will regulate that water, this storage water to the canal. This serves for multi-purpose function like hydroelectric power generation, flood control and fisheries. So not only we can supply water to the canal, but also we can have the power generation like hydroelectric power generation. We can have also flood control in the area where we can number of times the flood coming, we can control that flood by having this hydraulic structure, and fisheries also we can develop. So now in India we have trend of fisheries, and it has the government have initiated one business for the fisheries. So these things also can be developed, fisheries also can be developed through this reservoirs. Second is diversion headwork. So this weir or barrage is constructed across a perennial river to raise water level and to divert the water to canal is known as diversion headwork. So what is diversion headwork actually? Diversion headworks, that is weir. Weir means small crest, small height of dam. So just placed to divert the water from that. Or barrage. Barrage is with gate. I will discuss later this what is called this weir or barrage. But just for this you need to understand that for the diversion headwork we have to construct the weir or barrage across our source of water, that is river valley. So this flow of water in the canal is controlled by canal head regulator. So flow of water in the canal, we have to take out this canal from this area, this weir or barrage. So this can be controlled by one head regulator we have providing over this surface, and this is controlled by this canal head regulator. Okay. So what is the objective of this diversion head work? So I already told you before. Let's understand in deep. It raises the water level on its upstream side. So upstream side, whatever the rivers you have source of water, you have constructed the weirs over this surface. So some height is there. Okay. So this area the water will get collected. So this water level will automatically rise on the upstream side. Okay. It regulates the supply of water in the canal. This okay. It controls the entry of silt in the canal. This is very important. Entry of silt. So this flow with the velocity, with some velocity. So the water may have silt contain, will have some dissolved solids in it, dissolved soils in it. So this can be filtered. This water becomes still over this surface, means stagnant over this area, and then the top of the water will get out of the canal. So this is one structure we are having here is under sluices. These things also we will discuss in the future slides. Under sluices. So this under sluices is nothing but for the stagnant for the removal of the silt contained or some silt contained in the water. So we can control the entry of silt in the canals. Okay. It creates a small pond, not reservoir, on its upstream and provides some pondage. So in the terms of, if we are talking about the storage reservoir, we are talking about the reservoir, that is the most head of water is collected over that catchment area. But if you talk about the weir or barrage, this weir or barrage, then it creates a small pond, not its reservoir, its upstream side, to provide some pond, some head level, water level is increased. It helps in controlling the fluctuation of water level in river during different season. So it also helps in fluctuation of level of water in the river during different season. What you understand by different season means like in the monsoon the water level will increase, in the summer the water level will decrease, and winter it will decrease. So it also what diversion headwork will control the fluctuation of water. Now this question is very important in terms of storage reservoir as well as diversion headwork, that which area we need to select for this diversion headwork to construct. So this is very important because much amount of very large amount of funds are going to be invested in this all project. So we should have deep planning, long term planning for this, that which area, long term survey. If you want to talk with the terms of civil engineering, that long term preliminary survey, reconnaissance survey we have to do for the site selection of the diversion headwork. So this site selection should be narrow and well defined. So the river we are selecting for the hydraulic structure to get constructed. So this area should be narrow, means if your river is coming here, so maybe this area is broad. So the where we have to construct the hydraulic structure should be narrow. Okay, because so narrow we have to construct whole the mass concrete work we have to do. So this narrow area, less fund may be applied, and then it must be well defined. Well defined means it should have certain length, certain width. So it should be well defined in terms of everything, in terms of your hard strata also. The river should have this second is the river should have high, well defined, erodible and not submersible bank, so that cost of river training work is minimum. So same thing. So the rivers we have to select the site for the diversion headwork to be constructed. It should be have high and well defined. Okay, it should be non inerodible, means the area should not be that high velocity water is coming and eroding that area. We should avoid that site. It should be not submersible bank, so the bank should not be submersible, and the cost of training work is minimum. Whatever the training works we are providing, I will discuss in the later. Training works like you are having grounds, then marginal bonds, these all are training works we are providing before having construction of this diversion headwork. The canal taking off from this diversion headwork should have quite economical. So this things should be economical much and should have large commanded area. Large commanded area means the whatever the canal, the water we are taking off from this diversion headwork should irrigate more area of the land, more commanded area. Okay. There should be suitable arrangement for the diversion of river during construction. So suitable arrangement should be there of diversion. Then the site should be such that weir or barrage can be aligned at right angle to the direction of flow in the river. So this should be whatever I always drawing like this. Your rivers, so your weir or barrage is always perpendicular to that flow of this river. So you should keep in mind while selecting the site of the diversion headwork. There should be a suitable location for the under sluices, head regulator, other component of diversion headwork. So these things we will learn in details while I will discuss with the component of diversion headwork. Okay. The diversion headwork should not submerge costly land and properties of a stream. What happened actually when your this level head this pondage is increasing, so the your surrounding area will also get submerged. So you should keep in mind that it should not submerge your costly land or the non-agriculturable land. Okay, good foundation should be available at the site. So you must keep in mind that hard strata must be available there. The required material of construction should be nearly available at the site. So whatever materials we require for the construction of this diversion headwork should be easily available to the site. Okay, the site should be easily accessible by roads or rail, so that we can supply the materials, building materials. Okay, the overall cost of the project should be minimum. So in short, that the cost of the project should be minimum. Now this is very important, that is component of diversion headwork. So whatever we have diversion headwork we are discussing, what are the components of it, like weir, barrage, under sluices, divide wall, we have fish ladder, canal head regulator, silt excluder or silt prevention devices, and river training, marginal birds, guide banks, this all. So these things have much importance in the construction of this diversion headwork, and they play an important role in there. So you can see in the diagrams over here, this is a very important diagrams for the components of diversion headwork. So you can see here, this is the actually the flow of water they have discussed, they have shown that arrow. This is water flow of water. These are river training work like guide banks. This is guide bank, is written over here. This is marginal bonds. So these things are prior to the construction of this weir. This is actually a weir or barrage over here. So this first things, marginal bonds or guide banks are constructed before construction of this weir or barrage, just to avoid the submersible of the costly land. Okay, and these guide banks are provided to reduce the velocity of the water. Okay. Now I come to this point, that this is weir or barrage. So this is divide wall here between your under sluices portion. I have discussed in the last slide also under sluices. What it does, this divide wall help in reducing the velocity of the water. Okay, so whatever the velocity of water is coming over this area, it reduces the velocity of water over this. So water remains stagnant over this area. So what happens if it remains stagnant over this area? The whatever solid is dissolved in the water will start to settle down. Okay. Then we have constructed the canal head regulator over here. So this will settle in the under siliceous portion, and we can exclude from this by a silt excluder. Okay. And this then your fresh water without any silt, it will take out from the canal head regulator and will come to the canal system. Then here you have fish ladder over here. The main important of fish is fish having addiction of going from upstream to downstream side. So seasonal variation is goes like winter or summer. So if the height of this weir or barrage is high, so they don't die, we are providing this fish ladder. I will show you the diagrams of fish ladder, and it have minimum velocity of water. So it can travel easily from upstream to downstream. Okay. So these things we will discuss in detail each one by one. So what is weir? Weir is generally a normally the water level of any perennial river is such that cannot be diverted to the irrigation canals. Okay. So what is understood by perennial? Perennial means 12 months of a year. So perennial means it will not dry, the river will not dry in any season. Okay. So the water level of any perennial river is such that it cannot be diverted to the irrigation canals. So the bed level of the canal may be higher than the existing water level of the river. So in such case the weir is constructed across the river to raise the water level. You understand this? So whatever the level or bed is naturally in the river is contained, we cannot divert that water to the some area. So for that we need to have pondage of some water to divert that water to the canal. So for that purpose we need weir. Okay. So this surplus water, whatever surplus water, for example, you have rivers over this area, you have considered weir. So whatever after this crest, the top level is called crest. So after this crest, whatever the water, surplus water you have, you can divert that water to the this canal. So adjustable shutters are provided on the crest to raise the water level to some required height. So in the barrage, we have some gates over here. So we can also add some more water to the upstream side of the river. So actually the figure shown here, you can see the figure. This is weir. We have two types of weir: weir with shutter or weir without shutter. Okay. So weir without shutter, if you can see, so this is your upstream side. Okay. So this is the flow of river. You can understand the flow of river. So this water is total head of water, total pondage or head of water, we can say. It's actually pondage done in the upstream side. So this is crest level. Crest level means top level, or pond level also you can say. Okay. So here if you can design, if you can have by P1 and P2. So your P2 is 0 and P1 equal to P. Let's discuss this P1 and P2. Here you can understand better by P here. So whatever the pondage is done by this shutter is denoted by P2. So here you don't have any shutter. So here P2 will be 0 and P1 equal to P, total pondage. Okay. So P1 equal to P. I am talking about this picture. Okay. Weir without shutter. You understood, I think. Now weir with shutter. So here we have P1 as well as P2. Okay. So here P1 pondage by raised crest. So raised crest P1 and pondage by crest shutter we have P2. Okay. So this you can see every labeling of it. Crest shutter it is crest level and total pondage. So here if you are providing the crest shutter in the weir section, it is very important because you will get confused in the barrage. So if you are providing a shutter with the weir, then your P1 means pondage with pondage with the help of crest will always be greater than your P2, pondage with the help of shutter. So these things is very important, you should keep in mind. Now second is barrage. So when the water level on the upstream side of the weir is required to be raised to different level at different times, barrage is constructed. So we are having arrangement of adjustable gate or shutter of different types over this weir. So this is barrage actually. So barrage with the same figure here, barrage with a small raised crest. So we are having barrage with a small raised crest. Small raised crest means here we have seen the weir with dominating is crest in the weir section, but in the barrage dominating is shutter. So crest may be less. Okay. So this crest here in the last also we have seen here in the barrage section your P1 will be less than your P2. So P1 is pondage due to crest and P2 is pondage due to shutter. Okay. So here shutter is dominating. So whatever the pondage of water is done by gate is more than pondage done by crest. Okay. So this is pond level, gate is provided in the first with a small raised crest. Now barrage without any raised crest, it can be possible that without any raised crest, just you have, so here you have P1 equal to 0 and P2 equal to P. So this is very important, and I think you understood. Okay. So this barrage and weir is very important. So we have many variation of this weir or barrage based on different variation. So on basis of length and basis of crest, on basis of construction period, on basis of cost. So let's see one by one. If you talk about the barrage, your low set crest, you have seen the figure, you can have, if you don't have any crest, it can be possible in the terms of barrage. So here weir we have crest is important. Okay, high set crest. Ponding is done by gate. Okay, here ponding is done against the gate crest or partially against the crest and partially by shutter. So both important, with crest with shutter, or partially with crest or null by shutter, it can be possible. Gated over entire length, shutter in part length. Okay. Gates are of greater height in the barrage, shutter of small height 2 meter. Okay. Perfect control on river flow. In the barrage we have perfect control. In the flood also, flood area where in the monsoon season we have flood over the entire section, we can control with the help of the barrage, but we can't control with the help of the weir. So no control of river on low floods. High floods can be passed with minimum efflux, and here excessive efflux in high floods. What is efflux here? Suppose you have a crest over here, so these things passing over here. So this jump is nothing but efflux, jumps of water extra. So less silting upstream due to low set crest. Raised crest cause silting upstream. So this low silting is done in the low set crest, low silting in the barrage. Raised crest cause silting upstream. Longer construction period. So in the barrage, as we are having gates are more important. So you have construction period it is longer, in the shorter construction period. Silt removal is done through under sluices. So we are having silt removal through under sluices portion. We have seen under sluices in the component parts. No means of silt disposal. Here we can't do the silt disposal. Costly structure, and your barrages are costly. It's a weir is a relatively cheaper structure in compared to that barrage. Now third is under sluices portion. So it is also known as scoring sluice. What is known as scoring? If some deposition is done, we are eroding that deposition, that is termed as scoring. So this can be done under sluice is also called scoring sluice. These are the opening provided at the base of the weir or barrage. So here you can see clearly this is under sluice portion here. This is under sluice portion where the silt deposition is done. So scoring we are doing through this under sluices. So this is also called scoring sluice. These openings are provided with adjustable gates, and normally the gates are kept closed. So when we have to remove, gates are provided, then when we need to remove the silt, we open that gate and we remove the silt from that area. So the suspended silt goes on depositing in front of the canal head regulator. Okay. So whatever I told you that velocities decrease in that area, in the canal head regulator area, this portion. So this is your suppose divide wall. So this portion your velocity is reduced and the silt deposition is occurring over here, this area. Okay. So when the silt deposition becomes appreciable, the gates are open and the deposited silt is loosened with the agitator mounting on a boat. So this things we can have with the help of agitator, which are mounting on a boat. And the muddy water flows through the downstream to the scoring sluice. So the gates are then closed, but at the period of the floods, gates are kept open. So in the flood region, we keep the undersluices gate open as to prevent the damage of the weir or barrage. Okay. So you can see this portion. This is canal head regulator portion. Divide wall. The divide wall is a long wall constructed at right angle. Divide wall we have discussed here. This is the area. Suppose this is the area, and this is a flow of water over here. This is weir constructed, and this portion is divide wall. Okay. So this right angle to the weir or barrage. So it's always right angle to the weir or barrage. It may be constructed with stone masonry or cement concrete. Okay. So on the upstream side, the wall is extended just to cover the canal head regulator, and the downstream side is extended up to the launching approach. So in the downstream side is extended to the launching approach, and it is upstream side, it is just to cover the canal head regulator over this area. Thus the function of this divide wall is to form a still water pocket in front of the canal head, and suspended silt can be settled down, which then later be cleaned through the scoring slit from time to time. So what is also control the eddy current or cross current the front of the canal head. So the velocity is reduced, the eddy current is reduced. So the provided straight approach in front of the canal head is restrict the overturning effect of the weir or barrage caused by the pressure of ponding water. Okay. Now very important terms, fish ladder. I discussed in the brief in the fish ladder. So the fish ladder is provided just by the side of the divide wall. So here this is the things here. This is the divide wall, and this is fish ladder provided. This is your weir. So and this is your undersluices portion and canal head regulator over this area. So the rivers are important source of fish. The tendency of fish to move from upstream to downstream in winter, and from downstream to upstream in monsoon. So because of this addiction of the fish, we are providing fish ladder, and the movement is essential for their survival. And this due to construction of weir barrage, this movement get obstructed and detrimental of fishes. So you can see in the picture that this fish ladder we are providing to just minimize the velocity of the water by having this zigzag portion. Okay. And one slope we are providing to better movement of the fish. So see the section you can see. So in the fish ladder, fable walls are constructed. This is nothing but fable wall they are calling, in a zigzag manner, so the velocity of flow within ladder does not exceed 3 meter per second. Okay. The width, length and height of the fish ladder depends on nature of the river and types of weir or barrage. So actually the picture of practical picture of this fish ladder you can see over here. Canal head regulator. A structure which is constructed at the head of the canal to regulate the flow of water is known as canal head regulator. It's very important, it's very easy. So it consists of number of piers which are divide the total width of the canal into a number of spans known as bays. So the picture I will show you again. This is weir. Okay, this portion is weir. This is divide wall. This is fish ladder, and this is undersluices. Okay. Here we are providing number of piers, and this piers is nothing but these are known as the spans. Spans are called bays. Understood? So the pier consists of number tiles on which adjustable gates are placed. So here you can find the adjustable gates. Adjustable gate, okay. So the gates are operated from the top by a suitable mechanical device. So the platform is provided on the top of the pier for the facility of operating the gates. Some platform we are providing. Again, some piers are constructed on the downstream side on the canal head to support the roadway. So these things you can this can be easily understood. Okay. Function of this canal head. What's the function of this? It regulates the supply of water entering the canals. It controls the entry of the silt also, and it prevents the river flood from the entering the canals. So this is alignment of the canal head regulator. You can see in the picture the fish ladder, divide wall, under sluice pocket. Okay, this is guide bank, and this is off taking canal. So this is axis of the regulator. This is a piers, and we are providing this as this span is called base. Okay, and this is off taking canals. So here we are providing the gates also, and these are operated by the manually operating or mechanically we are operating the system. Silt regulation work. So from this we will have in the next lecture, as this lecture is very lengthy. So here I have discussed the components of the headwork, and mainly two types of diversion headwork or storage headwork we are having. So in the next lecture I will go through your silt regulation work, like a silt excluder and silt ejector, then your river training works, and more things are there. Okay, thank you.